Hey guys, welcome to Uncommon Lighting with Priyank, the Crypt of Rays. This is Priyank Ayas, your lighting family buddy. I'm a professional lighting designer. Guys, lighting is a very underrated field, but actually, it is a very vast field. So, my intention to create this channel is to aware about the lighting and illumination part. Before starting any designing, we all have to first understand the lighting fundamentals. So, my first module will give you the basic understanding about the lighting fundamentals and its terms. So this is the first module that called Lighting Fundament Part 1. I'm covering a few topic here and the rest topic will be in a part 2. So in a part 1, the topics are what is light output, luminous intensity, solid angle, beam angle, lux level, illuminance, CCT, CRI, glare, efficacy. These all are basic terms which will help you to do a lighting designing. So you guys all have to understand first what is light. So in a basic term, a light is radiated energy from any source. For an example, sun. Sun is a source. The sun throws a rays, that is a light. So you can say a light is a radiated energy from any light source. It's called as a light. Generally, light is measured in a 3 into 10 raised to 8 meter per second in a vacuum. This is the speed of light. Here I'm attaching a few figures. That figures will give you an idea about the wavelength. This is an electromagnetic spectrum. This spectrum is showing a different wavelength. If you will see the human eye has a very small spectrum, which is called as a visible spectrum. This is generally vary from 380 nanometer to 760 nanometer. So this is a visible spectrum. From this spectrum, we will able to see a light. Below this spectrum, it will be ultraviolet, it will be a X-ray, it will be a gamma, and above this, it will be a infrared, it will be a radar, it will be a FM. So different frequencies are there. So in order to emitting a light, we should be uh, vary a length between 380 nanometer to 760 nanometers. The second part is light output. So in general term, if you are a illumination student, you are probably facing a word luminous flux. Luminous flux is also known as a light output in a layman language. If you'll just focus on a definition, the light output is generally known as a total light quantity emitted by sources. Suppose, for an example, there's a one lamp. A one lamp is throwing some amount of lumen. So that particular amount of lumen is called as a light output. So lumen is generally the SI unit. So you can say that if you wanted to measure a length, there's a unit called meter. If you wanted to measure some height, the unit called feet. Similarly, a light can be also measured. So that measurement, the unit is also that unit is called as a lumen. Here I'm also attaching some chart. So whenever you are studying about any light product, there'll be a technical data sheet. In that technical data sheet, the lumen term is being mentioned always. So the wattage and lumen is always being there. That particular wattage is having such amount of lumen output. So lumen is basically an output of a light source. Luminous intensity. Intensity is basically, uh, if you will see the figure is showing you, this is a lamp figure, or you can say a torch figure. So light in a particular direction is calling intensity. So that intensity is generally measured in terms of candela. The candela is unit for a intensity. So you can say candela is equal to lumen per solid angle. Solid angle. Again, this is a very interesting term in doing a lighting designing. So solid angle is generally a ratio of area which is covered by light to us to, you can say, a radius square is called as a solid angle. So solid angle unit is generally a stadium, and the solid angle is also equal to area divided by the radius square. This is a formula for a solid angle. So whenever you are doing a manual calculation, this formula will be very helpful to you to identify the light emitted areas. The third is beam angle. So beam angle is very critical part in lighting designing. So whenever you are doing designing, the selection of beam will give you a better idea that how the light will spread away from a center line. So generally in a technical term, the definition of beam angle is the angle between two directions from which luminance intensity is 50% of maximum intensity. This is called as a beam angle. Generally in highway, in a downlighter or in a flood lighting, the beam angle are specifying a narrow beam, wide beam, or a medium beam. So narrow beam is generally a beam which is vary from 20 degree to 30 degree. Medium beam is generally vary from 30 to 60 degree, and a wide beam is generally vary from a 60 to 120 degree. So depending upon a different beam angle, the light spread and throw will be occurred. So this is a very important factor for doing a lighting designing. Again, a lux level. So whenever you are doing a lighting designing, this will be a very common nomenclature used by any of the lighting consultant, or you can say any of the client. Whenever you are facing a client, the client will give you that I want such amount of lux level. So you will have only a one constant value that is called as a lux level. So as per the IS standard, a different application has a different lux level, and lux level in general term it is also called as an illumination. So you can say 1 lumen per square feet is called as a 1 foot candle. 1 lumen per square meter is called as a 1 lux. So in general definition I can say lux level is equal to lumen per meter. So for an example, if I am turn on my light fixture, the light fixture is throwing a rays towards a work plane. It's throwing some amount of light output on a work plane. So that particular light output for particular area is called as a lux level. So lux level is defined for a various application. For example, in critical areas where light output is very essential, where critical jobs are being happening, the lux level are always be higher over there. For example, operation theaters, cutting and drilling areas in industries where lux levels are higher because critical jobs are happening here. In some application where only visibilities are required, they don't need to be focused on certain areas. For example, securities areas where lux level are tends to be lower because that application has no much intention to be higher lux level. So lux level is very important for doing any lighting designing. Illumination and illumination, this is a very confusing word for everybody, but it is very easy to identify the word. If you will focus on figure, a sun is radiating some amount of light which is called as a flux. It is throwing in certain direction is called its intensity. Suppose it throws on some object, or the object is particularly a work plane, so some amount of lights are spread on work plane is called as a illuminance. So illuminance in generally also called as a lux, or in FPS unit it called as a foot candle. So it is a very easy terms, illuminous. Similarly, luminous. Luminous is again a very confusing for everybody because both the words are seems very similar, but illuminous is something which falls on plane, and luminous is something which you see, which reflected something and comes to your eyes. So it's called as a luminous. So this is a very common word. Luminous is falls on surface, and luminous which is visible lux. So it is a luminous intensity per square meter of visible area. The SI unit is candela per square meter or a foot in FPS. This is a very simple word. Now again, before selecting any of the light luminous, the correlated color temperature is very essential. If you have guys noticed that some light is throwing yellow color, some are throwing white color, some are throwing a blue color. So this is called as a color temperature. So color temperature is something which is, for example, suppose a black body. This is an ideal object. If you will give a heat to a black body, the black body will start radiating a color, and we are matching that color to a light color. Is called as a correlated color temperature. So color temperature is generally vary from 2700 Kelvin to 6500 Kelvin. The more the lesser the temperature will be a yellowish light. Whenever the temperature is going to be higher, the light will be a bluish or white. So in different application, the color temperature are being preferred. For an example, if you have an application of reading, if you have an application where something the study and literature kind of job is being happening, the color temperature will be always a white or a natural light. In a hotel, in some reception area where you wanted to feel some relaxed atmosphere, the color temperature will be 2700 and 3000 Kelvin, where it looks like warmish and a relaxed atmosphere. So core light and color temperature is again a very important factors for selecting any products. Again, the next topic is color rendering index. Color rendering, the name in itself suggesting a rendering index means, suppose if you will just focus on a figure, whatever I am showing here, the more the CRI, the object will clear. The lesser the CRI, the object will not clear. So CRI is generally measured from 0 to 100. So more it comes to near to 100, the object will be clear. So it measures a light source ability to reproduce the various colors over the object with reference to a light source or artificial light. For an example, if I am using some downlighter and putting some object below the downlighter is being on, the downlightering throwing some light to object, that object will started reflecting its natural color. So more the CRI of the downlighter, the more the clear and natural color the object will throw. For an example, I would like to also give you a second example. Suppose if you are looking at tree in a night will be a less green. Whenever you see that same tree in a daytime will have a better green. So this is a difference between CRI. So CRI is nothing but ability to reproduce a various color is called as a CRI. So we always have to prefer the product which has a higher CRI. So in some critical areas where, as I already said, in operation theater, in workstation, in fabrication unit, where some critical jobs are being done, CRI is always being higher. Next is glare. Glare, in a layman language, the glare is called as an unwanted light. The lighting, why the lighting design is essential? Because if you are doing a proper lighting designing, you will able to get a proper and uniform light output. You'll able to get a proper and uniform lighting level in particular workstation areas. If the light level will be higher or if the light level will be over, that create the glare, and glare will give you a more difficulty to see the object. So more the glare, the more difficulty you'll face the object. So there should be always limit. So the limit is also mentioned in the table. This table will give you a limit. The UGR, that is a unified glare rating. So glare rating should be in technical drawing areas where the glare rating should be 16. Reading, writing, training areas where glare rating should be 19. Craft and lighting industry where glare rating should be 22. In heavy industry it should be 25. In railway platform it should be 28. So these are the limit which we have to take in a consideration while doing a lighting designing. In football stadium, in cricket stadium, in any kind of outdoor game, the UGR is always around 55 to 50. So the glare is very important factor again in a lighting designing field. The efficacy, as we have studied about lumen, as we have studied about the luminous intensity and all factors. Now, whenever you are selecting any product, the product is generally described with the lumen package. So efficacy is nothing but how much lumen output delivered by a particular product when I am just giving input to a 1 wattage is called as a efficacy. For an example, 3000 lumen product with a 30 watt will have a 100 lumen per watt efficacy. The more the efficacy will be, the more efficient product. So efficacy is the efficiency of a light source. You can say the higher the efficacy will be the better product. So nowadays the efficacies are more than 100, 120, 150 on a different application. We have a different product and different efficacies are available here in the market. So thank you very much guys for joining us. We will continue next session in the next part In the next part, I am covering also a few topics which will really very helpful to you to do a lighting designing. Please subscribe my channel, press the bell icon, and this will give you a notification on my updated videos. Thanks.